Hey guys, today we're going to be looking at surface area of prisms, which is lesson 10.1 in your book. The TEK that we're going to be focusing on is 8.7b, which says use previous knowledge of surface area to make connections to the formulas for lateral and total surface area and to determine solutions for problems involving rectangular prisms, triangular prisms, and cylinders. So let's take a look at some of these shapes that we're talking about. In this TEK, it's talking about rectangular prisms, triangular prisms, and cylinders. So let's take a look at what they might look like. This first group of objects, or three-dimensional shapes, are called rectangular prisms. The way we get that name is because these are all prisms. Every single picture shown here is a prism. A prism means that it has two bases that are the same shapes that are opposite of each other or parallel from each other. So if I'm looking at this set of pictures, two bases that are the same shapes, it would consist of this one, and you can't see the bottom. That would be the second base. This shape, we can count this as the base and the one we can't see that it's sitting on. We can say this is the base, and this one. Each one of these has two bases. Now the reason why it's called a rectangular prism is because those shapes are rectangles. Okay, if I look at this next object, okay, this object is called a cube. Now we all know that cube has all of the same sides. So the base here for a cube is going to be a square. Now remember, I can pick any two sides that are parallel because they're going to be the same shape. Every single side is the same exact shape. Okay, and then this last prism is called a triangular prism. Because the two bases are in the shape of a triangle. So we get these names pretty much from the shape of its base. Okay, now yesterday we talked about more specific things about prisms and cylinders and three-dimensional shapes. Okay, those things are called those faces. Remember, a face is the flat surface of a solid. Now, of those faces, okay, it's broken up into base and lateral faces. The base, which we just highlighted, for prisms there's always going to be two bases, and they're always going to be opposite of each other, which means that they're going to be parallel. Okay, since they're parallel, they're separated by the height of the prism, and we just stated that the figure is classified by its base, so we get the name of that figure from its base. Every other flat surface that's not considered a base is called a lateral face. The definition is just the remaining faces besides the bases. Now in this TEK, we need to find the total surface area and the lateral surface area. So there's a little bit of difference between both of those. First of all, total surface area. Sometimes they'll say total, sometimes they'll just ask you to find the surface area. When they do, they want you to find the sum of all of the faces' areas. Okay? When it's just asking for a lateral surface area, that's just finding the sum of the lateral faces. So that's going to exclude what? It's going to exclude the bases, which means that I'm finding the area of all the other faces, but not the bases. Okay, so there's two ways of finding surface area for a prism. That's what we're going to focus on today. We're going to look at the other shapes in this TEK later on. Okay, the first way that we can find surface area of a prism is from a net. And remember that a net is just really unfolding a 3D figure to make it flat. So the first thing we want to do is we want to label all the side lengths. Notice that they're going to give you some side lengths. If I break this all down, all of these shapes are rectangles. So with my knowledge of knowing what a rectangle is, I know that each of these has two sides that are the same that are parallel from each other. So if this side length is 6, I know this side length is 6. If this side length is 12, the opposite side length that's the same is going to be 12. So I'm going to label all my side lengths first. This side length's 5, so I know this side length is 5. This was 12, so I know this one's 12. Go ahead and finish labeling all of the side lengths of this net of a prism. Okay, when you're done labeling all the sides, check yours to make sure that they match up with mine. The second thing we want to do is find the area of each two-dimensional shape. Now, since this is a rectangular prism that's just unfolded, I know that the formula I need to know to find the area is going to be my length times width. So for each one of these rectangles, I'm going to find the area of using length times width. So this first one is going to be 6 times 12, which is 72. So the area for this rectangle is 72. The one that's under it, that's labeled the back, I'm going to multiply length times width, 5 times 12, and I should get 60. So this area of that rectangle is 60. Go ahead and do the rest by yourself. Pause it, and when you're done, push play again. Once you've found the areas of each two-dimensional shape, it should look like this, where I have two rectangles that are 72 inches squared. Always, when I'm finding the area, we always want to write our answer in units squared. Okay, so since my units is inches here, this would be 72 inches squared. The back is labeled 60 inches squared, 72, 60, and then my sides are 30 each. So now, I'm trying to find the total surface area here. So now that I found the area of each individual rectangle, all I have to do is add those together. So I'm going to add 72 plus 72 plus 60 plus 60 plus 30 plus 30. This year we're able to use our calculator, so I'm going to calculate all of this, and my answer should be 324 inches squared. So the total surface area of this rectangular prism is 324 inches squared. Now, I also wrote down the triangle formula for area because we might not always have a rectangular prism here. We might have the bases being triangles. So I need to make sure I know the formula for a two-dimensional shape that's a triangle, and that is just half times base times height. Okay, so just have that written down, so you might use that when you get into the classwork. Now, that was one way of finding surface area by using a net. The second way is by using the formula. Okay, using the formula, again, we might just be able to find the lateral surface area, which is everything besides the bases, or total surface area, which is everything. And I put pictures here because this helps me remember. Lateral surface area is everything besides the bases. So this is like a baby pen where we don't have a top and we don't have a bottom because the baby would suffocate, right? So we don't want to enclose that by the top and the bottom. So all I would be finding is finding the area of really like the fence part. Okay, that'd be lateral surface area. Total surface area is like for Christmas. If you're wrapping a gift, you want to wrap the whole thing. So you need to find the area of the present so you can wrap the whole entire thing. Now these two formulas are going to help us find the area of any rectangular prism. Again, lateral surface area is S is equal to capital P times H. That's just lateral surface area. Total surface area is S is equal to capital P times H plus 2 times big B. Now, the only difference between these two is this second part here. What do you think that part of this formula represents? Okay, you should have said the two bases. All of our prisms are going to have two bases. And remember, total surface area is the whole entire shape. When lateral surface area, which is our playpen or our baby pen, doesn't have those bases. So that's really the only difference. Now let's remember from last year what these letters represent. P means perimeter of the base. Perimeter should be very familiar to you because perimeter is just adding up all the sides. So go ahead and use a different color, and I want you to outline the perimeter of one of the bases. We don't need both of them. So my P means perimeter of the base. Now H is going to represent the height. Remember when we talked about and labeled the pictures above on this paper, we were told that there's always going to be two bases and the bases are separated by the height. So once I identify my bases, which again here they're triangles, I know that the bases are separated by that height. And the last letter that you need to know is going to be big B, or capital B, and that means area of the base. Now don't just think it's the base, it's actually the area of the base. So since this is a triangle, I would have to use the formula half times base times height to figure out that area of the base. That's when I'm using a triangle. Say it was a rectangular prism. I would be using length times width to figure out the area of that one base that is a rectangle. Okay, so that big B changes based off of what shape you're actually trying to find the area of. Okay, flip it over and let's continue with our notes. Now, in most cases, using the net to find the surface area is a really easy thing to do. However, there's going to be lots of times where you're not going to be able to find the area from the net. So we want to make sure that we understand the formula and we know how to execute that formula to get the correct answer. So here's our steps, and I'm going to refer to it as FSA. Okay, the first step is we need to determine if we're solving for the lateral or total surface area. So you're going to be given word problems. Okay, because STAR always gives you word problems. It's not just going to be the picture and making it easy for you. Okay, so you need to be able to determine, am I trying to find everything, all of the faces, or just the lateral faces and not the bases? Okay, the second step is we need to find the formula on your formula chart. So you will get that tomorrow, or if you have it, you're able to find the surface area with lateral and total for a prism. Third step is we want to highlight our bases, because that's going to help us determine what shape that 3D figure is that has the base. Okay, step 4 is draw the base to the side. Okay, that's going to help you find the perimeter of the base, and that just means that we're adding all the sides together. After that, we're going to determine the height between the two bases. Remember that the bases are separated by the height. Step 6 is if we're finding the total surface area, we're going to draw an arrow up from the B, or the big B, and say what shape the base is and what the formula is for the area of the base. And we're going to go through all this. Just make sure you have these steps right now. Step 7 is we're going to substitute the area of the base formula into your area formula. And then we're going to simplify our expression by using the order of operations. So FSA is the formula, substitute, and then we're going to find the answer. Okay, that's where FSA comes from. So let's do an example. Okay, this first example is a rectangular prism because I know that the bases are rectangles. Now, with a rectangular prism, we can choose any really bases, but they have to be parallel from each other. So I'm going to choose these two bases, and I'm already skipping down to step 3 because I'm going to find lateral and total surface area here. So I'm highlighting my bases. Remember, it's the same exact shape, and they're separated by the height of the prism. So once I do that, I'm first finding the lateral surface area. Remember, S is the surface area is equal to the perimeter of the base times the height. So if this stands for perimeter of the base, I'm going to take off that base and I'm going to label the sides. This is 5 inches, this is 6 inches, and since I know it's a rectangle, I know this is going to be 6 inches and this is 5 inches. So now I drew the base to the side. I'm going to find the perimeter by adding all those sides together. So 6 plus 6 plus 5 plus 5 is going to give me what? Okay, that's going to give me 22 inches for the perimeter. So now I have 22 inches for the perimeter. So I'm going to fill this in. I already wrote my formula. S is equal to the perimeter, which was 6 plus 6 plus 5 plus 5. And the H represents the height, so the height between the two bases, which in my picture it's labeled as 12. So now using the order of operations, I already have started it for you, but 6 plus 6 plus 5 plus 5 is 22. And then since there's no sign between these two numbers, I know I'm multiplying, so 22 times 12 is going to be 264, and we always want to label it with our units, so this would be inches squared, because remember, area is always squared. Now remember, that was just the lateral surface area, so we actually didn't find the area of the bases here. This is our playpen, our baby pen. We don't have the top or the bottom. But now we need to figure out what that top and bottom is, because now I want to figure out total surface area. Remember, the only difference between these two formulas is this part right here. So you already did all the work here. S is equal to the perimeter base times height is 264. So I'm going to go ahead and just plug that in for that first part, because I already did all that work. I'm not going to do it again. So now we need to figure out what the 2 times big B is. Now remember, B represents the area of the base. So I'm drawing an arrow up from the B, and I'm going to say what shape the base is. Well, what's the shape of the base? It's a rectangle. And how would I find the area of a rectangle? Well, I would do length times width. So now, if I want to do length times width, 2 just comes down. I don't do anything with that 2. But length times width is how to find the area of the base. So if I look back at my picture, to find the area of one of my bases, I'm going to do length times width. So 5 times 6. And now I use the order of operations to solve. I always rewrite everything down. I like to draw a line on my equal sign too. But 246 stays the same. Using order of operations, what would I have to do first? I have to solve what's in parentheses. So the 2 stays there. 5 times 6 is 30. And now I just copy down 246. 2 times 30 is 60. And my last step is I add those together. 246 plus 60 is 306 inches squared. Now you always want to double check your work. Okay, one way to easily do that is to make sure that the total surface area is always bigger than the lateral surface area. Because remember, total surface area, I'm just adding those two bases together. Okay, why don't you try one by yourself? Okay, go ahead and do the triangular prism by yourself. Pause it, and before you get to total surface area, push play to check your work. Okay, so step 1, determine if you're solving for lateral or total. I want you to solve for both. We're finding the formula on our formula chart. I already have written that for you. I need to highlight my bases now. So now I know my bases are going to be triangles. They're the same shape, and they're separated by the height. So now what I have to do, I'm going to rewrite my formulas again. I always write my formulas first to make sure that I copied it correctly from my formula chart. Okay, S is equal to the perimeter of the base times the height. So I'm going to pull off one of those perimeters. I like to draw it the same way that it's labeled so it's easier for me to label. This is 3, 4, and 5. So to find that perimeter of the base, I'm going to add up those sides. Now since it's a triangle, I'm only adding 3 numbers here. So 3 plus 4 plus 5. What did that H stand for again? Okay, it's the height between the two bases, which they've labeled that for me already, which is 6. So use order of operations to solve. I'm going to add what's in parentheses first, and I should get 12. And now I should multiply 12 times 6, which is 72, and this is feet squared. Okay? Next part is I'm finding the total surface area. So now I want those bases involved. So I already wrote my formula down. I already have solved this first part of the formula because it's the same thing. So I'm going to plug in 72 in for the first part. The 2 just comes down. And now I want the area of the base. So again, my area of the base is the shape, which is the triangle. And I'm going to do half times base times height. So I need to put in, I'm going to put 0.5 here because I'm changing that to a decimal because I like to work with decimals better than fractions. The base of my triangle. Now this time I'm going to change it. This is a right triangle, which we've just learn with the Pythagorean theorem, my two legs, this would be the base, this would be the height. So half times base times height would be half times 3 times 4. So I'm multiplying all of those together. So using the order of operations, 72 comes down, 2 comes down. I need to solve what's in parentheses first. So I'm multiplying 0.5 times 3 times 4. I end up getting 6. Next step is I multiply the 2 times 6, which is 12. And then I add 12 and 72 together, and I should have 84 feet squared for the total surface area of this triangular prism. Okay, again, total surface area should just be slightly more than the lateral surface area. Okay, so that's the basic computation of lateral and total surface area of any figure. Now let's match it up with a word problem. Okay, so the word problem states that Joanna is wrapping a present in the box shown. Find the amount of wrapping paper in square inches that Johanna needs, not counting the overlap. So first step is I need to determine if I'm solving for lateral or total surface area. Well, if I'm wrapping a present, I want to make sure the whole present is wrapped so they don't know what's actually in it. So I'm solving for total surface area here. And this shape is a prism based off of the picture. So the formula that I'm going to use is going to be S is equal to capital P times H plus 2B. Okay, now I need to find where my bases are. I'm going to choose this is my base and this is my base because they're already labeled. So finding the perimeter of the base times the height for our lateral first. So I'm going to pull off one of the bases, and I'm going to label the sides. This is 6, 8, 6, and 8. So in my formula, I'm going to add those together, 8 plus 8 plus 6 plus 6, times the height between the bases. So the height would be about right here, which is labeled as 1 foot. Now notice, that doesn't make sense to me at first because I just dealt with 6 and 8 inches, and this is only 1. Inches, inches, feet. So what do you think I should probably change to that 1 foot? Let's change it to inches. So we're going to say this is 12 inches because we want all of our measurements to be in the same unit. Okay, so I have my perimeter of the base times the height, which is 12 inches, plus 2 times the area of the base. What was the shape of our base here? It's a rectangle. So to find the area of that rectangle, I'm going to do length times width. So the length and the width of this base is 6 times 8. Okay, so you just did the formula. You just substitute everything. Now we have to simplify and figure out our answer. Okay, so right now, first thing I'm going to solve what's in parentheses. So in this parentheses, I have 8 plus 8 plus 6 plus 6, which ends up being 28. 28 times 12 plus 2, I'm going to multiply 6 times 8, which is 48. This operation here is multiplying, so I'm going to multiply 28 times 12, 336, and 2 times 48 is going to be 96. So I'm simplifying. All I have to do is add this together, 336 plus 96, and it's 432. Now what's our unit again? Remember we changed it to inches, so it should be inches squared. Okay, so the total amount of Johanna's wrapping paper needs to be at least 432 inches squared for her to cover up that whole entire present without anything showing. Okay, we'll work more on this tomorrow in class. Make sure that you know what you're doing, and if you have any questions, make sure you ask. Have a great day, and I will see you tomorrow.